Let me present you Dmitry Shipenok with his talk measurement end-to-end test coverage. Welcome.
Okay. Hi. Okay, I'm Dmitry Shipenok. I'm team leader at Ozon.ru, and I am tell about measurement of end-to-end test coverage. Actually, about all the external tests, not only end-to-end integration and so on. So, what kind of tests do you know? First of all, it's unit tests. We all know them because Go have a lot of tools to measure coverage, to check how good code coverage. But for all other tests, we have no such tools, and I'm going to talk mostly about all other tests: integration, external, end-to-end, all the tests that are external to your service code base. And the questions, how good are our external tests? How can we understand it? Yes, we have some metrics for business cases, but we have nothing the same as we have for unit tests regarding the code. And is there enough tests? How do you know? Maybe they do not cover all the cases we have in the code. And maybe some new ticket might not change business cases, but still have optimizations, improvements that increase the corner cases. So we still have to check it, but we don't know that we have to do so. And measuring the quality of tests. For unit tests, as I said, we have such metric like % of code coverage. For integration tests, nothing. So let's just measure it, because it's also possible, and we did it at Ozon. I created a simple example. It's a calculation API service. It has only 2 packages. The calc API package, which contains the main file, main function, some set of tests, and service package that contains processing of incoming requests, boring stuff. Okay, the main Go. Here you see our business logic, the multiply function and divide function. Takes into account division by 0. In main, we just create server, register the handlers, and create simple graceful shutdown, and start the server. That's all. Our unit tests are not perfect. We just check multiplication by 0 and division by 0, and that's all for now. Okay, let's modify our service that it will support measurement of code coverage for any external test. But to do so, we have to find some starting point. And we know that unit tests already do everything we require. So what is unit tests in Go? It's an executable file. You can easily find it in your temporary folder, but it will delete after test complete. It has different entry point, not main, different one. And if we request it, it contains special code for coverage measurement. So we have to do the following code changes: create entry point test main, described in standard package testing. Call main function from it, and get code coverage report. And don't break what already works. I mean, building the binary and the usual building, and our unit tests. They still should work after all the changes we'll do. Okay. For this, I created in package main, I created a file coverage test. So it contains test main function and calls our main function. But if we'll will not add anything else, then it will break our usual unit tests because it will run together. So we have also add build tag coverage. If we declare a test main function, we should care about everything now. So we have to parse command line arguments. And also we have to generate report. We're doing it with a little hack with testing main start and run the result. It's a hack because, as it described in Go documentation, they do not support this compatibility of this function. They might change arguments or anything else in any release. So if you use this approach, you have to check it. Maybe, for example, Go 1.12 will break it. And what we will do here, test depth is just mock. It returns default values. I can show you. So nothing special, just mock. And 3 nils is just 3 slices, one for tests, benchmarks, and examples. We don't need any of them, so we just use nil as a simple empty slice. Okay, to build the binary we require, the binary that will contain code coverage, we use standard tools. It's Go test. We add build text to it. C argument means that Go will not start the test after compile. Oh, I think we'll just set the path where to store the resulting binary. And we have to add cover package to cover all the packages, not only we going to compile. So let's do this. I prepared a simple project. As you see, everything I showed you before. So Go test minus text coverage minus C minus O, let it be calc API coverage. And D. Okay. Here is the binary. Let's just run it. Okay. And we parse the flags, not just safety, because we use it here. Cover profile, integration. Okay, everything okay. And let's just check it. Simple integration test. Use our curl. And let's check division. And ta-da, it works. And now let's stop it. Oh, you see the garbage here. And in this case, we have only one package with tests, but in your project, I hope there are more tests. So you will see a lot more garbage. We'll fix it, but now let's just see what report we've got. Again, use this well-known tool, cover and ta-dam. Oh. Yes, we divided 1 by 10, so we cover this part, and also notes that all the technical part also covered with test. Just keep it in mind. I'll get back to this. Okay, here's ours. So how to fix it? This output. We just need to reroute standard std and std output to def null, and then just return it back. So nothing complex. Okay, and that's our result. Yeah, 83%. Remember it. And for example, our developer decided to optimize our code. Everybody knows that multiplication is faster than division, and developer decided to replace division by 10 to multiply by 1/10. It will save a lot of time, about 1 nanosecond, but why not? Let's check it as well, what we will get. Yep. I'm lazy, so I use what's saved in my terminal. And here, and even here. So output is the same, already fixed. And integration out. And one moment. Okay. So, oh, the size. Sorry. So yes, that's our case exactly, and the coverage is 78 now. Yep, 78%. So noticed the coverage drop when we added this optimization. Okay. And what about performance? It might be possible that Go adds a lot of changes in the code, and it will be a lot more complex and will seriously affect our tests. Not really, and remember, the Go isn't magic, and you can check almost everything. This simple construction allows us to see what actually Go adds to the source file for coverage. I'll just mention the variable C. It's just a name of variable he will use to store the coverage information. The mode, it's set, atomic, or count, and everything else is pretty simple. So, yep. Go will just add such constructions. It's just to mark that code was executed, and it doesn't add it to each line. It's 2 blocks only. So you see, it's a 1 block without any conditions. So just adds 1 line, and at the end of the file, it adds some garbage structures. I don't want to talk about it, but it contains information about how many lines in each block and so on. Okay, and summary. How good are external tests? With this approach, we can just check manually the coverage reports we have to see what exactly they cover. Is there enough tests? We can set some threshold for each file or each package or the set of tests, and comparing it, we can understand, do we need more tests or not? Does new ticket require additional tests? Yes, as we saw, changes of the code lead to the drop of coverage. So yes, it's also solved. Our experience, yes. Integration tests usually intended to check the business logic. They do not intend to check our technical part. So they just execute it and test nothing. So it's better not to look at it and just leave only business logic part. Performance difference is negligible because I really tried to make some comparisons, but I failed because our staging cluster influenced the time of test execution a lot more. I cannot control other services in it, only my own, and somebody also started test at the same time. So when I made the measurements, it varies in a couple of times. So I didn't notice any differences between coverage, between binary with enabled coverage or not. Real profit we got in Ozone. We did it for our part of our business logic tests, checked them, and noticed that one files have no coverage at all, and another one is covered not so good. Most of other tests are more than 75%, and I set this value for myself that it's a good threshold. And the bad thing that when we covered this logic with integration tests, in both cases we found bugs. So it was real helpful for us. Bad news, yes, percent of code coverage is kind of unstable metric because developer can rewrite the code and it will change the lines count and the percent will change as well. For example, I replaced all the constants with variables at the beginning of the method and moved it there and made the coverage measurement and got the same 83%. But actually we didn't improve anything. So you have just to remember about it, and I think actually it would be nice to have in Go special mode that will coverage and take into account not the lines but blocks of code, and I think it's pretty easy to change, but who knows? Maybe I'll do this. What else we could make with this approach? First of all, we can measure full coverage with utility GoCovMerge. And the second, we can detect real dead code. I'll say later what is it. GoCovMerge installation is pretty simple with GoGet. Merge is also pretty simple. Just call the utility with files you want to merge. Only one thing you have to remember, that they should be generated from the same source code and have same coverage mode. I mean set, count, or atomic. Then just take and then just output the result and generate report. I already did it. And this is for unit tests, 21%. Remember, 2 tests at the beginning of our project. And this is 92 for merged coverage. Dead code. We have some linters to detect dead code, but I'm talking about different one. Sometimes we have some handlers, some functions that we in reality already never use. For example, we created second version of handler, and the first version used it so less and less and less. And at some moment, nobody used it already, but we don't know it. So we can run the coverage binary, maybe on staging, and just measure where other services use it or not. Maybe we can even run it on production and route to it a small part of traffic to check what code parts always read. Or maybe we can, if you can just record the traffic, real traffic, and route it to your service on staging environment and check the final coverage. We're still working in this way, so I have no examples, but we're thinking and trying to reach this point. And then yes, if you have red parts, you have they should draw your attention. Maybe nobody already used it, and you still support it, still have tests for it, still have code, and so on. So that's all. You can find the slides and example projects by provided URLs. And thank you. And any questions? And for two best questions, there are 2 T-shirts. Yeah. Microphone.
I'm running.
Have you tried to deploy binary with coverage in production?
No, not yet.
Why not?
I am a bit scary.
Thank you for your talk. I just want to know, how do you mock database or Redis and etc.?
Why do you need to mock database?
But if you, for example, want to test some from external library, and this one use, for example, database?
The main scenario here is that you do not require to mock anything, actually. You can just run the binary as usual one. It will just measure the code coverage, and you will receive the report after it.
Oh, okay, thanks.
Hi, did you try to write a generator for test main function? I mean, you have to write test main function by yourself, and it should be possible to write a generator for that. So you can just run your tool on any program, and it will calculate the test coverage of that program. Something like Go test cover is doing, but
no, I didn't try it.
But should it? I mean, are there any problems I'm not seeing right now? Should it be possible or not?
Sorry, I actually didn't get the question. Could you please rephrase it a bit?
Yeah, right now you just showed this on slides, this test main function, right?
Yep.
So for your project, you have to write it by yourself, by hands. And for any other project.
Yes.
Can we make a tool to generate this function for any project?
Yeah. Maybe we can.
So let's try that today.
Okay. Good idea. Thank you.
More questions?
Yep.
Thank you. What about tests on tests? Do you writing it ever?
Test for tests?
Yeah, tests
Why?
for tests.
Why should I?
Are you sure that your tests are working rightly? How can you be sure that your tests are right?
You mean correct? I'm not sure, but I can check that they really check the logic we have. So you just see the green parts, and okay, they at least call it. And if you have red ones only, then okay, guys, integration tests do something wrong.
Okay, so you believe that your tests are correctly working. Thank you.
Yeah. But I'll just add that I do not believe in my unit tests because I might be wrong, but integration tests, I believe in them.
Thank you for your presentation. When we prepare binary for integration tests, this is separate binary, not binary that we used in production. How to be sure that this binary behaves the same like production binary?
Maybe with tests. Just check if it works the same way. And as I show on the slide, that it doesn't make any magic. It just set the fields of structure, and that's all. So
okay,
it's quite simple.
Thank you.
Thank you.
Hello, thank you. Does it work with execution paths? For example, we have two ifs. we have do first, not do second on first test, and on second test, not do first, but do second.
Okay.
So case when we do first and do second doesn't cover. Do you have?
You can, if you really want to check it, I think you can set the coverage mode count, not set. There are 3 modes: set, count, and atomic. Atomic is mostly for coroutines, and count counts how many times each code block executed. So then you can see that, okay, this part's executed twice, and the and some part executed only once. So just not, but it requires some manual activity. I don't know. Maybe it's possible to automate if you really need it.
Thank you.
How do you know that it's time to stop to writing the test? In which % you stop?
As I said, the threshold is 75% in my case.
It's enough for you.
It's enough for me, yeah.
Okay, thank you.
Thank you.
Did you consider possibility to write a test package, import server to that package, import client to the same package, and like run like usual test?
Sorry, just.
For example,
could you simplify?
Yeah, your server code was in main function.
Yeah. It's just to simplicity.
Yeah, you can make like some exported function, and then import it from other package. And the same for client. You can make request function in some client package, and then import it to the same test package, and then run this test package covered by usual unit tests.
I didn't try it, but I think you just could merge your results of different tests, if I understand you correctly.
No, it's a bit. You write this main test function, but instead you can import the packages you want to integrate in the same integration test package, which is just package for this integration testing, and then run it like in one binary, client and server.
No.
And then, for example, you can start server as Go routine and in the same
one binary.
Yeah, in one binary. And client code you can run as test.
I have to think about it because it's not so. We can talk after the break.
Okay, you're welcome.
Thank you.
Thank you. Do you have some rules to have different kind of tests for your services? For example, rules to have unit tests and integration or end-to-end tests. And if some logic is covered by unit tests, should it be covered by integration or end-to-end tests?
I think the better approach is to cover business logic with external tests, and unit tests have as much as possible. Because as I showed in some slide, with our real business logic, all the code covered with unit tests, but we still find 2 bugs when we added integration tests.
So integration tests are primary for you?
No, not primary. I can't say it's primary. It's primary for business logic that it works as we expected. But we also check the code with unit tests because we have to be sure that there are no small nasty bugs that will break the business logic as well.
Mm-hmm.
Just to like a test pyramid, just to decrease required amount of integration tests.
Okay, and threshold is the same for unit tests, for integration tests?
No.
75
No,
persons.
no.
No?
For unit tests, it should be higher.
Higher than 75.
Yep.
Okay.
We have time for a couple more questions. No, then you have to decide who gets the prizes.
Okay. Let me think. One winner, you know him, is about utility for generation of, I don't see, what? Anyway, you win. And the second question, I think is yours about different blocks and how to find that didn't cover it with tests. Yep. Thank you.